The topic I decided to look into was kerosene cooking and its uses. To start with, I'll explain a little what kerosene is, in which Chilcott 2006 says it's a liquid fuel that's similar in composition to diesel, obtained from the distillation of crude oil, seen here in the diagram, in which the kerosene hydrocarbons cool off at 170 to 250 degrees Celsius. Kerosene, or also named paraffin, has various uses. However, its main use is aviation fuel, due to kerosene being a main component in producing jet fuel. Other uses include household heating, powering cookers and lamps, as well as everyday products such as cleaners and paints. It can also be used in other vehicles. However, due to it only producing 10 litres of kerosene per barrel of crude oil, this makes it economically unviable. Kerosene is most largely used by African and Asian countries in the use of cookers and lighting, although the UK does still use kerosene in houses for heating. This is due to it being easily bottled and transported compared to other sources of fuel, allowing rural areas who aren't attached to any electricity grid or gas pipelines to get their fuel, as there is a predicted 1.3 billion worldwide who still lack electricity. Kumar and Viswanathan 2016 says India promote kerosene and LPG fuel with subsidies. This is done so market price fluctuations are at a constant price, meaning the populations can budget to buy these bottles. Kerosene is also a lot cleaner than some biofuels that they burn, which have effects on the environment and cause health issues correlating mainly with respiratory diseases. However, although kerosene may be cleaner for the environment than burning coal and wood, it still causes greenhouse gases, such as carbon dioxide, and creates soot when burned as a liquid, known as black carbon, which is due to incomplete combustion. Black carbon is the second biggest contributor to global warming, as it absorbs more sunlight than carbon dioxide, but only stays in the atmosphere for a few weeks, whereas carbon dioxide stays in the atmosphere for over 100 years. Kerosene use also still causes health effects, with Tesden 2013 saying in India 2.5 million suffer severe burns each year from overturned kerosene lamps. So although it is a cleaner source of energy for communities when compared with the likes of coal and other fuels for burning, it does have negative effects and is a key contributor to climate change. Many organisations have pushed to stop the use of kerosene lamps because of the black carbon and the inefficiency compared with other sources of energy, in which SolarAid 2013 give us some startling statistics, such as with a comparison that 7 to 8% of kerosene lamp emissions are black carbon, while diesel engines are around 0.001%, and 1 kilogram of black carbon produces as much atmospheric warming in a month as 700 kilograms of CO2 does in 100 years. These issues show that there are much better replacements or ways to use kerosene. However, with more investment into the energy and household energy mix in areas such as India, you can have much cleaner and safer energy that will help sustain the future with a reduction in CO2 emissions, with the possible use being solar, wind, geothermal, and natural gas all being great replacements. However, for now, even MEDCs are still using the likes of kerosene, as these have large setup costs. But as the Nobel Peace Prize winner, Kirk R. Smith, is quoted saying, "There are no magic bullets that will solve our greenhouse gas problem, but replacing kerosene lamps is a low-hanging fruit. We don't have many examples of this in the climate world." If we cut the use of kerosene lamps in particular, it will cut down black carbon by a predicted 270,000 tonnes, which is the equivalent of 4.5% of the USA's carbon emissions. Thank you for listening.